Hello everyone, for First Updates Now, I'm Tyler Rolls, and you're watching Behind the Bot. It's fun show. We dive deeper into FTC robots and what makes them work. And today I'm here with team number 16750, Technototes from Bellevue, Washington. 16750 has started out with a strong start this season, 131.1 OPR at their first event in the Washington Spencer League Meet 1, and they have a great narrow robot with a powerful linear slide elevator. Joining me today from 16750 is going to be Kim, Tristan, and Alex, and we're going to be detailing the full overview of this robot, of course, following the freight journey through the robot, talking about the carousel, some of the code that's gone into this robot, maybe some future iterations. All this and more coming up on Behind the Bot.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
First Updates Now is supported by Kettering University. On average, Kettering students earn $45,000 to $70,000 over the course of their co-op program to help them graduate debt-free. 99% of students qualify for a merit scholarship, and you can apply for one of the 80-plus first scholarships worth up to $25,000 each. Schedule your virtual visit to get started at kettering.edu. Fun is gearing up for the 2022 season and is looking for advertising partners that would be a great fit for our fans and also make it possible to keep us creating great content. If you're interested in your company or brand reaching over 100,000 unique individuals who are actively engaged in FIRST for either recruitment, brand positioning, or product engagement, go to firstupdatesnow.com/info or reach out to us at admin@firstupdatesnow.com for our advertising partnership deck, and let's get your brand started on First Updates Now. So Kim, we're going to start out on this robot talking about your intake area and then of course following that freight journey through. So talk to me about what's gone into your intake and any future iterations you might be looking at as well.
Our intake is honestly pretty simple. We just 3D printed almost everything with it. We 3D printed a ramp under here so we can have our flaps intake right in. We also put these flaps right here to make sure freight wouldn't get stuck under our robot, since that seems to happen to a lot of teams. We can show you guys real quick. You want to show it? Kind of hard to. There we go. And it goes right into our bucket over here.
So looking at the initial design process, when you were thinking about like, hey, this is what we want to create. I love that you had those additional spots so that you don't drive over the freight on there. What was kind of some of the process that when you started prototyping that you went through? Like, did you just put something together and go for it, or did you have a couple different prototypes in mind initially?
We went through some CAD prototypes. Like we had a field prototype or field CADed as well to see how the robot would fit on the field, and a lot of test driving, seeing like if the robot would tip over when we would drive over freight and kind of where the freight would go as we were driving.
Well, next up, we're going to keep following the freight in the robot and going into your slides and the scoring mechanism. And actually, I didn't even see this in the initial video, a really cool way that you're kind of doing this multi-stage slide, essentially. So talk to me a bit more about it, Tristan, and what went into it.
Yes. So on our slides, we have 2 stages of 400 millimeter slides. And then we also have one 300 millimeter slide that just goes horizontal to give us a bit more reach and allow us to place freight towards the center of the goal easier.
And send it up. And it allows us to get...
Yeah, and then so with these slides, the goal can be all the way like over here and we're still able to reach it. And even if I manage that wire correctly, we can dump over the center pipe of the hub and onto the other side.
What made you think about wanting to go with like having the vertical slide and then the horizontal one there instead of, we see a lot of teams just kind of put a dumper at the end of their vertical slide?
So in our initial CAD prototypes, we noticed that we needed the height of the 2-stage 400 millimeter slides, but we also needed the extension of the 300 millimeters just to like get over the hub, and it would give us a bit of a bonus in autonomous.
Mm-hmm.
And then, looking into the future for this area as well, any potential changes you're looking at making, or has it been working out just great for you?
For the future, we're looking at improving our whole dump assembly up here, because currently it can just dump out here, and sometimes it like chucks the freight of it, and it's like a bit inconsistent with these servos. So we're looking at improving that for our next league meet.
And then from your scoring capability wise, do you typically only score on the top part of the hub, or are you able to score on all 3 stages?
We're able to score on all 3. We can score on the high goal, in Teleop or in the shared hub. So it has a shared hub height and a top hub height we can access in Teleop.
Got it. Makes sense on there. And then we'll keep moving on to Alex, who's going to be talking about the carousel mechanism that you have, and then some of the code that's gone into. Just love to hear about what you're doing, but during auto and teleop for this as well.
Okay, so we have a carousel mechanism. It's pretty simple. It's just a motor, a wheel attached to a motor, such as bot. So we can control it with 2 buttons, and that allows us to get all the ducks off the carousel with enough time to park in the warehouse at the end of the period. On the code side of things, one thing we really wanted to focus on is making sure we had a really good autonomous, because freight and autonomous get scored twice. So we use a wide variety of sensors, ranging from range sensors on the side of the robot, like right here, and out in front over here, as well as using encoders on the drive motors in the middle. So we can we have 2 forms of accuracy when we're running autonomous, so we can go faster than we otherwise would.
So let's talk a little bit about vision on your robot and what you're doing from that standpoint, Alex.
So basically what we did is we had a camera at the back of our robot hiding in this channel right here. And this allowed it to be very protected from a match jump whip, because there's a lot of defense and a lot of rough terrain to go over. So it worked great. This camera allows us to see the 3 different barcode locations pretty great. We can demo it on the screen, I believe, for the camera. So camera stream. So Johnny can zoom into the camera stream and it should be able to update. I can tap to refresh. So if we're centered on and refresh, it says barcode is 1 because in the center circle. If we moved it over about here, we refreshed again, it would say barcode. It doesn't pick it up. It would say barcode is 0 because it's on the farthest one this way. And if we moved it all the way over here and refreshed again, it would say it is in barcode position number 2. And this allows us to get the 20-point bonus in autonomous, which really adds up.
One thing I want to ask your team, I don't know who wants to take this, but your team has decided to go with the narrow robot, right? You're able to get through that extra gap on the side. So when you were looking at a decision process standpoint of that, obviously the more narrow you go, you got to potentially have some other limitations. What made you want to go with a narrow robot? And then, I watched the match. You were able to just negotiate the field very nicely that way too.
Yes, Tristan can take this.
Yeah. So in our initial strategy discussion, we noticed how beneficial autonomous was to scoring really highly, since the freight gets counted twice. For that, we decided to go the narrow bot route so that it was easier for our autonomous to do everything we wanted it to do and not lose accuracy.
Well, your team's performing really well so far. I can't wait to see your next league meet coming up and what changes you're looking to make to your robot as well. So once again, we have 16750 Technototes coming in from Bellevue, Washington. Good luck through the rest of the season, and thanks for taking time to tell us more about your robot.
Yep, thanks.
Thank you.
Thanks to Kettering University for their support of this video. Kettering University is a national leader in experiential STEM and business education. Discover why so many first alumni come to Kettering University by scheduling a virtual visit at kettering.edu. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow. And check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.